Hello everyone, welcome to Code Soul. Thank you for coming by. I'm Beej, I'm the founder. I also work at this company here and help set up all this stuff. But today, Jason will be presenting on HP server from scratch in Python. I do recommend checking out our Discord in case you want to check where the online stream is and all that kind of stuff so you can reference it later. You can find info about our Discord on the meetup event. Or if you want to go back and reference a recording of this event later, you can just search Code Soul on YouTube and you'll be able to find us. But with that, I'll turn it off to Jason. Thank you, Jason.
All right. Yay, round of applause, round of applause. Woo, we're so excited. Since I usually, before we start, we have like 15 minutes. I usually just like chat shit, figure out what the level of programming it is within the people that came. But I bit my fucking tongue, and it hurts to speak. But I'm gonna do this anyway because I said I have to. So, before I actually get into all that, I do actually need to know the level of programming that everybody has. Just like, are you beginner, intermediate, advanced? Just, who's beginner? Raise your hand. Okay. Who is intermediate? Raise your hand. Okay. I assume nobody is here as senior enough to be advanced because all of you look pretty young. Okay, cool. And another disclaimer, this is not a tutorial on Fast API or Flask. If you were expecting that due to our description, which did not mention Fast API or Flask, then yeah, you're just wasting your time. You can just leave, right? But if you're not, oh, I saw you. Okay, if you want to leave, then I don't really care. This is gonna be about writing a HTTP server, which is just a basic server that most websites use to serve HTTP files. And we're gonna try and I'm gonna show you how it is, made from scratch in Python so that you can better understand the technology that you're actually using. This is particularly more relevant to server-side backend developers, but the actual mechanisms of receiving and responding with HTML documents as an HTTP request and response is also relevant to client-side applications. So if you do front-end, a little bit of this, the actual code would be useful. But before that, I'm going to cover the network layers, TCP, HTTP, what are these things? If you're beginners, you've likely never heard of them. If you don't really work with a lot of network programming, like backend or client, you may have never heard of them. So I'm gonna have to explain these things first. And after that, I'm just gonna explain the project a little bit and then just dive into a demonstration, use a debugger, walk through the code, all that kind of stuff, right? So yeah, I'm a backend developer with 2 years of experience. I work with Python and Kotlin. This is not a lesson on Fast API or Flask. Just get out if you're expecting that, read the documentation, watch YouTube, whatever. And this is, please learn how things work under the hood. If you have imposter syndrome from being self-taught or from being a boot camp, it's because you have no idea what's actually going on. You're just gluing together libraries, right? So if you don't want to feel like that, actually learn how things work. So I'm going to talk about this. From all of the CS topics that I've studied, I think computer network theory is the second most boring theory that I've read. The first most boring is database internals, boring as hell, right? But this is second, so it's a little bit more bearable, all right? I'll try to make it a little bit more, bearable, right? Hold on, I need to look at the notes. So when we connect to Wi-Fi or connect to a LAN cable, right? We are sending data across the network. And when we send data across the network, they go through all of these 7 layers, right? Which is called OSI, which is short for Open Systems Interconnection. And in, I guess, a bit more recent times, these 7 layers have been sort of coagulated into these 4 different layers. And I'm going to explain what each layer does, starting with the OSI, because that came first. And you'll kind of learn why they are kind of smushed together into the TCP/IP, the box here, right? So what happens, right? So let's say this phone, I'll just call it D because the labels here are D and C. These will be relevant later. My phone sends a GET request, right? It sends a GET request. Does everyone know what a GET request is? Does everyone know what a GET request is? Also, am I going too fast? It's fine. Okay, I tend to go fast. So this phone, I'll call it D, right? It sends a GET request to this website, right, on this port. And it sends HTTP header, cookies, and content type, all of that kind of stuff in the header. We're going to explore what these things are later in the code. And this is the very first layer, right? This is what the actual application does. And the HTTP server, right, it encrypts if necessary. So the difference between HTTP and HTTPS, right, the S means secured. It means that the data being sent over the network is encrypted, right? That is the main difference. So encryption can happen if necessary. And next layer, in layer 5, it gets a session tag, right? So it tells these receiver of the request, hello, hello, please take a seat. Oh, because new people are here, I have to say this again. If you're here to learn about Fast API or Flask, get out. This is not about that. No, okay, cool. Oh, since new people here, I'll have to go back again. Yeah. So I'm gonna first explain about computer networks, TCP, HTTP, and then I'm gonna explain the project structure. And yeah, and I'm on to the, I think, in my opinion, the second most boring part of computer science, networks. So this phone is called D, right? Why it's called D will be relevant later, all the way in layer 2. But this phone is called D. Let's say the computer that it's connected to, hypothetically, is this computer right here that I'm using, this MacBook, right? Let's call this C, right? So first, this phone, it does a GET request to this address and this port, right? It attaches HTTP headers and cookies and all the other like content type data. And it encrypts the data if necessary. And that's the difference between HTTP and HTTPS. The S stands for secured, which means that the data sent over through the network is encrypted, right? Hashed, right? And then it establishes a session tag saying this request is part of like this session, so that when multiple requests come and go, when the actual data it ends up being recombined. Yeah, I'm not gonna do that again, but like a new person just came, whatever. So the session tag, it just identifies which request is which, like which like different requests, because a website can do multiple HTTP requests to get a lot of data back at the same time. They can request for the CSS files, the JPG files, the HTML files, and the JS files. So each request needs some kind of a like session ID, right? That's how I understand it. And this is layer 3, right? This is layer 3. And this is the application layer. This is just what happens in the application layer and what the actual application does, right? That is sending the network request. Layer 4 is transport. And these layers onwards just gets a bit weird, right? So the first thing it does, right, it gets this data, encrypts it, establishes a session, adds a bunch of headers, all that kind of fun stuff. And layer 4 goes, hold on, that's too much data to send over at once. I'm gonna break it apart and that's what it does, right? I'm gonna break it apart, and it adds ports. So the destination port is 80, as defined here, and the port here is the source port, right? In case the server needs to send anything back or whatever, due to like, I don't know, whatever reason there may be. This is the source. So this would be the port of this phone, right? Right? If this is sending the network request, right? And because it is broken into different segments, it needs to be ordered, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because when it gets sent over, it may not arrive in order, right? And the receiver, the server, it has to reassemble all of these like bits together to form the actual entire message being sent, right? This GET request. And this is what happens in layer 4, right? And then, right, you see these extra information here are called headers, right? The headers got added to this in HTTP request over here. It also gets added here. And in layer 3, the network layer, right, more headers get attached, right? We just really like to attach headers, right? Have you seen these Russian dolls, these Matryoshka dolls? That there's big dolls, you take one out, there's another one but smaller. Yeah, it's the same thing, but this is what happens to the data, right? So in layer 3 network, right, it attaches the IP address of the I guess like how do I explain IP addresses? I actually can't, right? I forgot to review this part, but yes, please help me, Beach.
All right.
Yeah.
So come over there for
Yeah.
So an IP address, right? You know how you know your apartment building or villa or wherever, office tower, wherever you live, you have an address, right? So let's say you live on like Gangnam-daedo here. You're very lucky if you can make that kind of money. Let's say you're like Gangnam-daedo 100, right? And then you live in Gangnam-gu, which is in Seoul-tukbyul시, right? Which is in Republic of Korea, right? So each of these are kind of a way to kind of group regions, and it's an arbitrary grouping. In the case of the physical real world, it's grouped based on geography, right? But with the internet, there is no geography, right? It's just electrons going back and forth, so geography doesn't matter. So you can think of each of those segments, that 10.0.0.3, right? That 10 is like Republic of Korea, right? And then the first 0 is like Gangnam-gu. The third 0 is like Gangnam-daedo, and the 3 at the end is like, you know, house building number 100. But do be aware, that does not correlate to physical space. You can have 10.0.0.3 be like here, and 10.0.0.1 be in like Mexico, right? This does not correlate to physical space. But it's basically a way to guide networks on how to route traffic, right? So if you give like the post office a letter, and you say, here's the address, the post office knows how to go to Korea, and then to Gangnam-gu, and then to Gangnam-daedo, and then building 100. Same thing with IP addresses. The routers know how to say, okay, 10 is this way, 0 is that way, 0 is that way, 3 is that way.
Thanks. Yeah. Yeah, I forgot to review that. Okay. But I remember what the MAC address does, right? MAC address, people probably never heard of it. So in this network layer, the split up parts get new headers, attaches IP addresses. And then this data here, it also gets split, right? You can see that it's not split super cleanly, right? There's the D and the C, and the D and C. The D and C here are the source computer and the target computer, right? This is D, this is C, right? It arbitrarily like cuts the data apart, right? And these MAC addresses are connected. And these MAC addresses on the network is a unique identifier for each computer, like this or this, that is connected to the network. So it would be, I guess, like a human like name or like social security number, like something like that. So because they need to figure out, okay, so which IP address do I go to and which computer do I go to, right? And yeah, and because they also split it apart, I guess it wouldn't be remiss to say that they also like include the order in which to like combine these like pieces of like data together. This is the data layer, right? And finally, all of this is turned into zeros and ones because some like crazy guy in the past figured out how to turn electricity into data, right? So this is why we have all this stuff going on, and we can like post hateful comments online and just like watch videos of chats and all that kind of stuff because some freaky guy learned how to turn electricity into numbers, right? And this is what happens when you send it, right? And when you receive it, the same thing happens, but in reverse, right? This is turned back into data, right? Right, and it figures out, wait, hold on. This, hold on. No, I think I got it. This gets turned back into data, and like layer by layer, it figures out where it needs to go, right? In the data layer, it figures out which computer it needs to go to, and like which IP address to go to, because after it gets converted back, it is already this like compressed and just there's already compressed and just sort of like all bunched together with all the bunch of headers that we have. It figures out the IP address, and then figures out the port, right? And with this, the various like hardwares used for networking, like routers and computers, it can know where to send the network requests, right? The only thing encrypted here, if it is encrypted at all, right, is only this part. This part here, like the port, this part here, the IP address, this part here, the MAC address, it is not encrypted, right? It is just there for the network hardware to use, right? And and then it just uses all this information to send it to the right computer, and then finally at the application layer, it decrypts the data as necessary, and just responds with the data. And this is just a very high-level overview of how the 7 layers work. And I think this is almost as far as you need to know as developers. Like this would just sort of explain the fact that when internet is slow, sometimes it is your fault because you are sending a whole bunch of data, and sometimes it is not your fault because random packets go missing. Because this is literally just electrons, shooting across like seafloors through like cables and all that kind of stuff, right? So sometimes it's your fault, sometimes it's not, and sometimes you just have to pray, get a religion or something, right? So I'm gonna talk about TCP. I talked about TCP a lot, blah, 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 blah. Oh wait, but before I go further, do people have questions? Yeah. Yeah.
Where is the payload? We have headers, but where do we put the payload?
Payload is part of the first HTTP request.
So each layer, get on the mic.
Yeah.
So each layer may or may not have its own headers, right? Like the payload is always there because, the payload is what's getting sent, right? So there's a payload all the way from 1 up to 7. Now, I'm not as strong on layers 1 through 4, but I think, is TCP 3 or 4?
TCP, it's 4.
4, okay. So at layer 4, right, it'll inject some headers to be like, hey, this is the packet order and that kind of stuff, right? But then also for like layer 7, for HTTP, it'll also inject HTTP headers, right? So the headers and payload, it depends on which layer you're talking about. These things really do stack on top of each other. So for example, your layer 7, like HTTP request, right? That has its own header and payload, right? But because that's too much information to fit in a single network packet, it's going to get split into smaller packets, and those packets may have their own header and payload. So it's kind of everywhere. Does that answer your question?
Yeah, okay. When you meant payload, did you just mean like a JSON body or something like that? Okay, yeah. That is stored, that is first like sent with, layer 7. Yeah. And I think I do need to show you what a Matryoshka doll is, or maybe not, whatever. It's just, there's a bunch of data, it gets split apart, and then more data gets appended, split apart again, more data gets appended to it, and later it's all smushed together and reformed. Yeah. Does anybody have more questions?
Is the HTTPS encryption happens in the layer 6 layer, or does it happen in the
Oh.
or the HTTPS, because S stands for encryption?
Yeah.
Does it happen in the presentation layer, or does it happen in the physical layer?
I think logically, right, these layers don't really need to know what's inside the HTTP request. It only needs to know where to send it to and how to combine the packets, right? This is what layer 1 through 4 needs to know, right? After it gets sent to the right computer and right port, it does need to decrypt it and to show it to the user, right? So logically, if I think about it, it just happens here, right? Questions? No questions. Is anybody in the chat asking something? Nope.
I have checked.
Okay.
So for the TLS stuff, like, this is all a model of how stuff should work. When we talk about HTTP, right? I'm not going to see history here. I'll check out there in a second.
Yeah.
When we talk about like TLS for HTTP, so TLS is the S part, right? It used to be called SSL, now they call it TLS. Anyway, the security part. That can be 6 or 7, depending on what part of it you're talking about. So there's arguments that it could be 6 or 7, because like it's all fuzzy, right? It's just people writing code that make this stuff work. So the lines can get blurry sometimes.
Yeah. So that's why it's like smushed together, right? Like the bottom 2, network access, smushed. I mean, transport and network, they're pretty distinct. So split up, and all of this like actually showing to the user stuff and all that, and just getting stuff from the user, all smushed together into the application layer, right? Right. And this is the big bird's eye view of what happens, right? Cool. I love it when there are no chatters. Oh my god. I don't have to interact. I don't have to interact with chat. You know, I don't have to be like a streamer. Hey, chat. You know, what do you think about this? You know, well, no.
You're a streamer now.
I'm a streamer now. You know, I'm gonna quit my job. You know, release a data structures and algorithms course. You know, how to get into FANG. Wow. Gosh, I'm so fucking.
All right, let's keep going.
Yeah. So I'm gonna talk about TCP, which is short for Transmission Control Protocol, and it is the like method used to just transport data in layer 4. And layer 4, it doesn't have to be, I think, TCP. There are other protocols like UDP, which is called User Datagram Protocol. I did not review that much information about it because I mostly use TCP, and I'm just like, oh, what the hell is TCP? Let's review that. If you have questions about UDP, I probably won't be able to answer them. But know that, but UDP and TCP, if I were to compare them to like people, TCP is like the super strict by the books person, right? And UDP is like more chill, right? He's drunk all the time. He's like relaxed with the rules. He likes to jaywalk, likes a bit of DUI, you know, a little bit of like theft, you know. He's like fine with that, right? Yeah. So TCP, it's just a core protocol used in layer 4, and it just, all the stuff about it being reliable and by the books is because of these features, right? A key to providing reliability is that all transmissions in TCP are acknowledged, right? Let's say I give Beach this cup, right?
Actually, no, let's do it.
Yeah. And if I give this cup to Beach, right? Beach has to say, yes, I received the cup, right? And after I've acknowledged that, when he returns back to me, it's like, oh yes, I've received the cut, right? Like there are, when computers like communicate each other with like the TCP protocol, there's like a whole bunch of acknowledgements going on. Like, hey, yes, I received this. Yes, I'm finishing the connection and all that kind of stuff, right?
So do it again.
Yeah.
So let's say he hands me the cup and I don't take it. What happens? Right. You gotta,
Yeah.
it waits
Yeah.
until, you know, the acknowledgement happens.
Yeah.
But if there's no acknowledgement, it's not gonna wait forever.
Yeah, it's gonna stop. Yeah.
Timeout.
Yeah.
Yes. You get a timeout.
Yeah, you get a timeout. Yeah.
Do you know sin axonac?
Yeah, syntax and I got the.
Explain that.
Yeah.
Okay,
There it is.
cool.
Yeah.
Sorry.
Yeah. So before an actual like TCP like connection is established and data is just like transferred over, like this thing happens, it sends the client, right, the person making the request, it sends SYN. They say, hey, I received a SYN. And he said SYN and ACK, which is short for acknowledged, right? Acknowledgement, right? And then it receives the SYN, receives the ACK, and then sends the ACK again. And the server just receives the ACK. And once this happens, the client and the server are ready to talk to each other, right? They have made sure that they're connected, right? A three-way handshake, because they do it 3 times. And when the connection closes, they do something similar. Client sends FIN, receives the FIN, and also it does, and the server returns the FIN and the ACK, right? Say, hey, I acknowledge the finish. And the client is like, hey, I acknowledged the acknowledge the acknowledgement of the finish that I sent. And the server is like, okay, I acknowledged that you acknowledged the acknowledge of the finish, right? And then the server just like stops talking to the client, right?
This is a popular interview question. Nudge, nudge, wink, wink.
Yeah. And this is the acknowledgement. It just makes sure that these two things are connected, right? Hold on. And connection oriented. This is reliable data transfer. Yeah, because of this, like all this, like whole like acknowledgement process that occurs before data is transferred. It is just an incredibly reliable way to just send data over network. It keeps track of data that has been sent and received, and it makes all of it just to the destination, just without exception. You can't guarantee that data will always be received, but however, it can guarantee that all the data will be checked for it being received and checked for data integrity, right? And it can be retransmitted as needed, right? If something that was sent is not correct, it will retransmit it, right? So this makes it quite slow. I mean, this already is quite slow, like not in terms of humans, but in terms of like computers, slow. And this like transmission control protocol, this like reliable data transfer, making sure everything's sent and resending things if it's not properly sent, it makes it slow. But you gotta have like upsides and downsides. Another one is just connection oriented. This is sort of like more related to the handshakes that we have here. It just really makes sure that establishes a connection before they send data, right? It's analogous to like a phone call, right? You ring until the other person picks up, and then you just like talk that way, right? You don't just shout into the void and hope that the person you want to talk to is hearing what you say, right? And congestion control. TCP has a way of knowing that if it's sending like too much data over the network, and if it finds that it's just sending too much data over the network, it will sort of reduce the amount of data it sends, right? So that is not to overwhelm the network, right? And finally, is stream delivery. So in the previous slides, we showed that the data just gets all like fragmented and like ripped apart. But when it actually sends the data, it makes sure that all these like packets and like fragments, all that, they're all combined together into one coherent like data, and it just sends it as a stream to whatever is receiving the data, right? It doesn't care as long as it receives a stream back, because they'll just like rip it apart yet. But It just makes sure that all the data, the person receiving the data, the computer, it just doesn't have to care about just reforming the data, right? This is stream delivery. So this makes TCP very reliable, but also very slow, right?
By very slow, we mean like adding 2 milliseconds.
Yeah, 2 milliseconds, unbearably slow. Yeah, I could solve a lead code easy in 2 milliseconds. No, I'm just kidding. All right. And before I go on to HTTP, does anybody have questions about TCP? Yeah.
So the terminating, so terminating connection, it
Yeah.
happen after finish of the data like sending.
When a connection terminates is, it depends on how this protocol is used, right? This will be a bit more apparent when I talk about HTTP, but in some cases you can just terminate the connection after you receive all the data, or you can just keep it open. You can just keep it open and just not finish the connection. Do you have more to say?
Yeah.
Yeah.
So TCP has like this open and close behavior, right? Opening connection, closing a connection. There's also a keep alive, right? Because, because the receiving end needs to make sure that things are ordered, needs to basically maintain effort to maintain this connection. The connector wants to let the receiving end, hey, I'm done talking, we're done having this conversation, because it takes resources to maintain a connection, right? It has to spend CPU cycles, it has to spend a file handle, socket, all this kind of stuff to maintain the connection. So by explicitly sending a terminate handshake, it lets the other side know, hey, we're done talking, you can reclaim your resources, you can close the connection, right? Otherwise, what will happen is if you just terminate the connection without doing this termination handshake, what will happen is the receiving end, it'll be waiting to hear that keep live message to let it know, hey, we're still talking, I'm still communicating. If it doesn't hear a keep alive, then it'll just be like, okay, I guess the other side closed the connection without telling me, and then it'll reclaim the resources. But this is generally considered kind of bad behavior. If you've ever seen like an error message like remote host closed connection, right? It means that, they might have just terminated the connection without doing the proper closing protocol. Or if you see a timeout after you've already connected, it might be because, they didn't do a proper close. So that's the kind of, basically it's for reclaiming resources and letting both sides know we're done. Now, there are long-lived TCP connections and there's short-lived TCP connections. So for example, when you do a normal HTTP request, like, just going to a web page, that's usually a short-lived TCP connection. You send a request, you get a response, done, connection closed. But if you're doing something more complex, like WebSockets, for example, or if you're doing something like a chat application where it's meant to be like real-time chat, you may just open up the TCP connection and then just keep it open, keep sending keep alives, so that messages can stream directly without having to go through these handshakes all the time. But when you do that, it takes resources to maintain a connection, so there's a cost. Now, when it's just one connection, the cost is like negligible. But let's say you're running a service like Discord, for example, you have like hundreds or thousands of connections, that cost matters now. So you want to make sure that you close connections when you're finished with them to manage resources properly. So does that answer your question? Cool. Sorry.
Beej is a real infrastructure nerd. I mean, I wish I had the skills because like DevOps and SRE just get paid so much. It is unbelievable. They type a bunch of YAML files and click UI and they get paid so much money.
Jason, I have to say,
Yeah.
it hurt my soul when you said database internals are the most boring thing. I love database internals. How could you do that?
Have you read books? I mean, those books are just, oh god,
It's this big, it's fine.
oh god. I need picture books, man. I need like I need like Subway surfers on the side and like a Minecraft like videos on the other side and just, oh my god. Anyway, any more questions? No questions? You sure? Okay. I'm gonna get some water. My mouth feels like fire.
I'll
Yeah.
get you water. I'll
Yeah,
get you water.
yeah.
Continue, I'll get you water.
Okay. My plan to take a break has been dashed. All right. So finally, HTTP, right? We're not gonna cover like this part, network, data link, physical. Oh, thanks, Beach. Right. For this, I would need to need actual equipment, and as you can see, I just brought my computer. Right. I can't do that. This part, we're done. Now we're gonna talk about this part, right? Right. This part, this nice fat application layer, right? So basically, what HTTP server does, and before all that, what HTTP stands for is Hypertext Transfer Protocol. It is just how do we transfer text, right? And I don't know exactly why it's called hypertext, but whatever. But it transfers text, right? And text can be read by browsers and rendered into UI that we all use and just take for granted. And they also send, and they mainly send along with like the payload, AR, just HTML. And if you're front end, you know that they stand for hypertext markup language, right? It's just text, the register markup language, which is parsed, and yeah, which is just shown to UI every single day, right? So this is what an HTTP server. Where is my mouse? Oh, it's over here. It's over here, and yeah, this is what an HTTP server does, and this is really not too different from what a normal like backend server does. It listens, it parses data, and applies logic and blah blah blah, and responds. But the few differences that exist between like an actual HTTP server and like an actual like backend server that we're kind of more used to if we're backend engineers is that this HTTP server, right? It directly, not here. It directly gets the data from here, right? Here. And this is just a stream of bytes. And they have to parse it into a somewhat usable and legible format. And this is what it does. And this HTTP server, as a result, just has a lot of logic to just like parse the logic from this byte data to figure out what's the URI, what's the method, if there's a body, what's in it, what are the headers, and all that kind of stuff, right? And it has to handle multiple connections at once, and yeah, all that kind of stuff. And this HTTP server is kind of at the base of most like backend frameworks and libraries, right? Express, Fast API, Flask, they all use like some sort of like HTTP server or like some kind of like async like runtime, async like HTTP server that allows just the parsing of HTTP into JSON bodies and convenient like header files like dictionaries to be used. I think Express probably also uses something like that. I don't know the actual what it would be called. For Fast API, I know they use Starlet, and Starlet isn't exactly like an HTTP server, but like beneath Starlet, like a dependency for Starlet would be something like an HTTP server, right? That parses all this kind of stuff. And for like Spring Boot, they use something like a Tomcat server, for example. But anyway, you guys have to know that like beneath all these like huge like popular libraries exists something like this, right? And if you just understand like the basic like stuff, switching between frameworks become very easy because you get to have an understanding that if this is a backend framework, I would be able to find things that can map routes to methods. I will be able to find things that can like get headers from the request, and I would be able to find things that can get bodies from the request and all that kind of stuff. So yeah, just understand things so that when you learn frameworks and stuff, it's just easier to switch to and easier to get up to speed. and it's easier to debug also when problems happen, right? So finally, the most exciting part. Woo.
I'm sorry, can I interrupt?
Go ahead.
Can you show an HTTP request?
An HTTP request. If I put a debug on the project structure on the project.
Just Google an image.
Oh, okay, yeah.
Yeah.
Hold on. Let me.
We have to assume that these folks.
Yeah.
Yeah.
HTTP request. Hold on. I am finding. Okay. I think I found one. Yeah.
Yeah, perfect. That's just actually yeah, that works. Cool.
Yeah. I think this would be a HTTP request. Yeah, and this has the verb.
This one's better. This
Oh.
one's better.
Okay, cool. So there's a request line. There's a post.
I'm sorry.
Yeah, go ahead.
So real quick, when it comes to like all the different layers, right? HTTP is at layer 7, right? It's at the top. It's kind of the simplest form of networking exchange. Now, HTTP is a text protocol, right? Remember hypertext markup language, right? So all the data is just text. Now, in a normal HTTP request, you can also send like images and audio and all that kind of stuff over HTTP, but the protocol itself also uses text, which Jason's going to explain in a second. But all that said, when it comes to this networking stuff, right? If on layer 7 you're not using HTTP, you're using some other thing like WebRTC, right? Then it wouldn't necessarily be text going back and forth. It might be like binary bits, which would be like video data or something. But with HTTP, it's a really easy protocol because it's text. We as humans can read it, and that's why it's become so popular. So that's some kind of context around what Jason's going to explain. All of this is text, okay? Now, don't expect every protocol to be text, but HTTP is, and hopefully that makes it easier to understand. Sorry, I just really needed to give that context because if you go to do other networking, you're going to be like, what the hell?
Yeah, what he said. So yeah, this is what a request looks like. It's usually not this pretty. It's usually just like a bunch of ugly bytes, but it's been like parsed here nicely. So this is the post request, and because it's a post request, it has a body, right? This is like a JSON. This is separated between the header and the body by just one new line. And then here are just all the headers, right? All the headers that the server needs to know how to respond accordingly, right? Here you can put in like a cookie, right? A bearer token, an auth token. You can put stuff like how to cache, whether to cache or not, all that kind of stuff. And yeah, just a whole bunch of information that you can put here, right? All this metadata. And this is what it looks like. An HTTP response looks also pretty similar, right? Yeah. I guess it doesn't have the request line, right? I don't think it does, at least. Yeah. When I implemented it, it didn't have it, and it just worked fine. Yeah.
But the key part is that
Get this on the recording. The key part to understand before Jason dives into the code is that this is the format of HTTP, right? So there's all different kinds of protocols. The HTTP format, the specification, you can go look it up online of like how to create an HTTP request. It is this text, right? So you have an empty new line between the header and the body, okay? The header, you have different values. Each value is separated by a new line, and the header name is some text followed by a colon, space, and then the value of that header. Okay, that is the format of an HTTP header, and then the body is dependent on, you'll see this content type header up at the top there. You see the content type is application JSON, and it tells you what character set it's using, UTF-8, because who knows, maybe you're using like ASCII, just pure Latin characters, maybe using Chinese characters, whatever. But the application JSON tells the server, hey, I'm sending you data in JSON format. Maybe you could also send the data in XML format, which can represent the same type of information. So the headers are mostly for the server to interpret. And then the body is for the application to interpret to do whatever it is, right? In this case, this is like an API call, probably, because it's JSON body. But maybe the message, whether it's request, response, whatever, maybe instead the payload is HTML to show a web page. Or maybe it's binary data that's an image, right? The body can be whatever you want, and you specify the type of data being sent back and forth with a content type header, right? Now there's a whole bunch of different headers, like Jason described, but this is the format, okay? So headers are header name, colon, value. Once you see a blank new line, that means the headers are done, and then you have the body, and the payload can be whatever the hell you have told the server the payload will be. JSON, image, whatever. And then do you want to explain like the method and the path and all that?
I'm just going to go over that when I explain the code.
Okay.
Yeah. All right. Enough theory. Let's go over to the code. Right. So, hold on. I need to see what the hell is going on. Right. You know, it'd be really good to have a standing desk that's just like this. You know, I think it'd be really cool. So, here we have a simple server. This is the HTTP request, as shown in the example. Right? It has headers. It has the method, post, get, whatever. HTTP version it's just there. Right? It's 1.1. There's the URI. Right? It stands for Uniform Resource Identifier. It identifies which resource that we're trying to get to. And this is the body, right? And it can just not exist, right? It's fine, right? This is the body, and this is the request. And the response, right? It has the status code. Was it a success? Was it a failure? Was it not found? It has headers and the response body, right? And this is the HTTP response. Very similar, but slightly different, right? Right. You can look more into the detailed implementations later, or when I just like run through the code, right? And this is the HTTP server itself, right? That I have here. But before I actually dive into the code, I have to go into the TCP server. This is layer 4 stuff, right? Here you can set the host, which is the actual like address, and the port. Here it is 8888. I put it here. And TCP server.start, it will start just listening for anything trying to connect at this address and at this port, right? It will just open a socket and just keep waiting, right? And it just binds it to the host and the port and just listens. It just starts listening, right? So there's infinite loop going on, like while true. So unless an exception happens, or unless like something like just tells it to close, it will just keep listening for requests, right? It's gonna read the data, right? Reading the data is also like another discussion, but I won't go into it now yet. It will read the data and it will handle the request. And this handle request function is here. It takes the bytes, it gets the client socket, and it just sends it back. So this is just a simple echo server, right? It takes whatever it gets from the client and it just sends it back. And this is, I guess, like how a lot of like chat applications work. When you send something to Kakao Talk or like Instagram DMs, once you send it, it also shows up on your screen again. So yeah, this is what an echo server does. And to demonstrate it, hold on, let's go to main.py, comment these out. TCP server, nice. I am going to, I'm just going to run it. is listening at this, I am going to send a request. I think it is. What was it? TCP. Oh wait, hold on. Missing hostname and port. Hold on. You know, I've been experimenting so much with HTTP that I forgot how to do this. Never mind. Wait, hold on. Let me just check something real quick. Oh my god. Oh, okay. No, I put in the wrong command. The host, the port, and JSON. This should work. Wait, is it? Hold on. Oh, let me just run it again. Wait, hold on. Sorry, let me just this is weird. It should have worked.
Pair programming time.
Yeah.
Now let me see.
Resource temporarily unavailable. In buffer read client socket.
Is something else already running on that port?
I don't think so.
Do a netstat. Are you on WSL or Windows directly?
This is just a Mac, so it just.
Oh, it's a Mac. Okay.
Yeah.
So do here. Let me help you out.
Yeah.
God damn. No, nothing's running there. Try again.
That's weird.
Oh, yeah, it was working. Oh, yeah.
Huh. Wait, let me just change the code quick a little bit. Oh, whoops.
Just receive one packet.
Yeah, because it's just something just small. Yeah. So, what was going on was that when it receives data from a client, right, it doesn't know necessarily how long bytes the data is going to be. So what I originally did was it was doing a buffer read. So while buffering is true, and while there is just more data to be received, it will just receive more data and just append to the new data, right? And finally, if there's a blocking error, buffering is going to be set to false, and it's going to return the result, right? For some reason, that doesn't work with the TCP data. This works fine with the HTTP server, but okay, let me just test this. It should echo.
Okay, cool. You didn't send anything.
Huh.
No, that was right.
It was.
Yeah.
It connected and it should have sent something back. Send all. In that case, let's start debugging.
Well, I don't think you sent any data.
Did it not?
No, you didn't type anything.
Oh.
You sent Jason.
Yeah. Hold on. Let me just.
Yeah, do that. And then type Jason.
Oh yeah,
again.
Jason. Yeah.
There you go.
Yeah, it returns something back. It echoes something back. Yeah. So this is what a TCP server does. It just basically just takes whatever data and just can do whatever you choose to do with it. If I debug this, right, stop and rerun, I'm going to first establish a connection. Then I'm gonna send JSON, and boo, okay. So first, it's accepting requests. So it accepts the first request. The client socket, it receives the data. I don't know why it's called recv, but it's a weird truncation. It gets it as bytes, and then it just gives it back to the handle request function. And inside, right, it's going to send it all back, and then finally close the socket, right? And it's just gonna keep doing that. Just gonna keep doing that. And as you can see, it has just returned and it's just closed the connection, right? That's what a simple TCP server does. It just receives the data and there's no logic, right? All of the logic, right? All the parsing and the, recombining the data, just formatting it as bytes, it all happens inside the socket library that's provided by Python, right? I don't think trying to implement this level, I think it's a little bit overkill, right? So I just didn't do it. It's just right there. So yeah. So to return it to something like for HTTP, right? No, go away. This is a TCP server. Any more questions before I go over to HTTP? No questions? No questions, okay. So, right? So what the main difference, right? This has just way more logic. And the handle request is overridden from the TCP server, right? Here it's simple, but here is a bit more complicated. First it takes the data and it creates a new HTTP request. Then it figures out what kind of function to use according to the method. The method could be get or post or whatever, right? And then it gets the response, and then it returns the response to the client socket, right? Who here doesn't understand what first-class functions are? Functions as first-class objects. Okay, cool. This is not related to network programming, but it is, I guess, a little bit related to this code, so I'll explain it here. So let's go to get handler. So as you can see here, these are functions, right? Normally, when you just use a function, you define it somewhere, then you just call it, right? With using the brackets and you put stuff in here, right? But sometimes, right, you just want to kind of just figure out, you just want to use these functions as variables themselves. Yeah, like integers and strings and bytes and all that kind of stuff. Basically, you use the functions as variables because, internally, in some languages, functions are just objects, right? Like classes or objects, they're just in a weird format, right? Right. To my knowledge in Python, like when you define a class, right, there's a magic dunder method, right? Wow, so cool. I'm just gonna make it a static method, right? If I did something like HTTP, well, does this work? Wait, hold on, no. Let me, no wait, no, this is going off topic. Anyway, I will stop here. It just means that functions are objects and can be used like variables. That is the main thing, right? And here the type is callable, right? So you can call this function, so it's called a callable, right? And let's look at each handle get, handle post, and handle 501. First, a get, right? A get, no wait, before that. Let's see what happens when we get a new request, right? It's just in bytes. And as we told you, this whole parsing thing in the text is very important. So the parsing logic is here with this function. It takes bytes, right? It does a whole lot of just like string and byte formatting. This is here. This here is trying to parse the headers. And if the content type is JSON, we will try to find the body, right? And we will also try to find the URI. And we'll also try to find the HTTP version, right? The reason why we probably need the HTTP version is that each HTTP version, like 1, 2, and 3, they all do the same thing, but slightly differently. I won't cover it here, but it's just enough that I guess like browsers need to know like which kind of HTTP version that we're using to communicate, right? It parses all of the data. I won't exactly just walk through the code because it just works, and just returns the data, and then it creates a new instance of the class, right? This is where all of the parsing happens. If the HTTP server, after it gets the new request, it's going to get a handler based on the method. If it's a get, it will get handle get. Let's look at handle get. So it gets the URI, which in this case would be a hello.html or index.html. It's gonna go to the directory that contains the file, right? So because we found it, the status code is 200. 200, we found it. Nice. It's gonna read it, and then it's gonna, the response body is just added to the HTTP response. If we don't find it, the status code is 404. Oh no, so sad. And then we send this back, right? And extra headers, none. Encode the response. And this is what the, hold on, where is it? HTTP response class does. It takes all of the information and it just encodes into bytes to be sent to the client, right? This to response here, what it does, it gets the response line and just turns it into bytes. Response headers, it takes the headers, adds the extra headers that we may have got, and then it just encodes it, right? And then it gets added, instantiated into the class, right? And this is what it does. And we're going to look at the post method when we need to create a resource. So it's gonna get the, first it's gonna create the name of the file, right? Request party.name. So what I'm gonna send here, right, just as a teaser, I think it's this, yeah. I'm gonna send a JSON with just one field, name and JSON, right? It's going to take the name, create the file, and then it's just going to create a HTML file. Right, just open, F, and just write and close. And since we created it successfully, we send a 201. Nice.
Can I explain something about this open thing?
Sure.
Okay. So, quick thing about networking in Unix systems. This is different from Windows, because Windows is, let's just say I have opinions on Windows. When it comes to Unix-based systems like Linux, Mac OS, it treats connections like files. Everything in Unix is a file. And when you have a network connection, what it actually does is it creates a file on the file system that's not actually a file. It's a file on the file system. You can write data to it, but instead of writing that data to disk, like you would expect a file to do on a computer, what it does is it writes that data to a connection. So what he has here is the I misunderstood your code.
It's
I'm
fine.
sorry.
Yeah. What he says is relevant if you're more advanced. This is just Python code.
Yeah,
Yeah.
I'm sorry. My bad.
Yeah.
Never mind.
Yeah.
I jumped up because I thought you were like writing directly to the stream.
Nah. I don't.
But-
But-
Might as well though.
Yeah.
So if with like the HTTP server stuff, I'm sorry, with the TCP server stuff, what you could do is you can open a socket as a file and then just write data to it directly. Now that would be a lower layer, but this is something completely different. He's just reading, or he's just writing it to an HTML file and then just sending that file. You could just write the stuff directly too, but this is easier to see and you can also have a record of it. So
Yeah.
sorry.
That's fine,
Sorry,
that's fine.
I messed up.
Right. Yeah, it just writes, it creates a new HTML file. All right, let's see what happens. This worked like an hour ago when I was testing it, 2 hours ago. If it doesn't work now, then somebody up there hates me. I don't know. Let's run, let's go. It's listening, yay. In the terminal, let's look at what I got here, scratch. First, we're gonna get index.html, right? Hold on. Yay, worse. Oh my god. Yeah, it returns with a nice HTML response. If we go to a browser, where the hell's my browser? Oh, there you are. 127.0.0.1 888/index.html. Yay! We made our very own web server. I think the very first web servers were like this. So yeah, if you want to really go old school, just try something like this. Let's look for something that doesn't exist. Pokemon, Pikachu. Yeah. Not found. Yay! It's perfect. It's perfect. Amazing. Let's look for the hello file. Hello. Yay, we got it, right? Amazing. Such a god programmer. Nice. All right. Now let's create something, right? Let's create something. Oh, hello there. This got created and returns with this, a successfully created HTML page. And if we go to hello_JSON now, we get JSON's page. Nice, super cool. So let's go through the debugger and just look a little bit more slowly at what happens, all right? I am going to stop and rerun in debug mode. Okay, nice, that works. First, let's look at handle request, right? Here. First, I'm going to send a request. Index.html. Let's go to index.html again. The data here is just a bunch of ugly bytes with all this crap here. Ew, nobody likes it. right? And now we're gonna go here to see how it is parsed, right? Let's go here, resume program, and nice. So what it does here, right? It splits into several different lines. So the first line is the verb with the like URI. So URI here is not a URL. It identifies the HTML file, right? Because normally we used to just exchange HTML files, right? The host, the user agent, blah, 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 blah. And then just like line by line, we are going to we find that the request line is just this, right? And then we're going to parse the headers. Just go through a for loop so basically after the first line, they could all be headers, maybe not. So we just go all through them, we decode, we split by this, and then we add it to the headers dictionary. So host, user agent, accept, blah, blah, blah. Beautiful. Content type, it doesn't have a content type, so we skip over this, and then just like simple more parsing, right? Oh, what did I do? Never mind. What did I do? Oh no. Oh, it worked. Never mind. Let's send the request again. HTTP server. It gets the handler. Oh, never mind. Just get rid of these breakpoints. Going to resume. Okay. No, wait. Another one. Resume. Okay. Where is the handler? I'm pretty sure it called this function. That's weird. Huh, why isn't... Oh, special variables, okay. Yeah. So yeah, functions can be used as variables, so cool. This gets pretty nifty uses in some cases, so it's good to know. And not all languages support it, but the ones that do, goated. All right, let's go inside the handle get. You see, this is a handle get. Handle get. Where is it? It's over here. Right. Oh god, okay. It's gonna first, what? You know, man, sometimes the debuggers, I just don't understand how they work, right? Maybe I have to write a debugger myself to understand, but like, what the fuck? Yeah, I'm just gonna send the request again. Huh. Maybe this debugger can't detect like if it's actually using handle get because it's using this function as a variable, but that's apparently what's happening. That is weird. But anyway, this part is just like not too exciting. It just finds the file, reads it, and returns it. Right? That's what it does. And the post is also just not super interesting, right? It does this here, all that. And yeah, and this is a very incomplete and very like simple implementations of an HTTP server. You can see that a bunch of verbs are missing, like delete and put. And it also, in the response file, we're only doing these 4 status codes. If you've done more web programming, you know that there's just like a whole bunch more status codes, and a proper HTTP server would implement all of that, right? There's probably like a couple hundred, to my knowledge, maybe less, maybe more, I don't know. And yeah, this is basically on how an HTTP server works. Pretty simple. It just takes the data, parses it, and can do logic with it you know, maybe not. And this is, yeah. Any questions? No questions? Anything further that you would like explained? No. Okay. Since we have a bit of time, why don't I try to implement another verb? Right, HTTP server. Go away. Handle delete. Request. HTTP request. So, I think I'll just copy this. So here we're trying to handle a delete, right? So we need to find the file. Just copy this here, add the file name here, and there should be the path to the file. If os.path.exists, we're not gonna open it. os.remove the path, and I think we're going to just I don't think there is a response body for the delete. Maybe just something simple. Success, right? And now, typo here. Go away. Fix this. So case, delete, return self.handle delete. Handle delete. And if we do send, oh my god. If we do this, I think this would be a delete implementation. So let's just try deleting the hello.json HTML that we just created. So is it still, yeah, let's stop and rerun. I think what I need to do here, okay, curl x delete hello json.html. I think this should work. Oh wait, what's the command for delete in curl? The delete in curl. Is this it?
No, it's capturing delete as a proxy. I think it's a capital S.
Oh wait, oh it's capital. Oh oops.
I think it's been a while.
Yeah.
Also, alt or option arrow will
Oh, okay.
do by word.
Oh. Huh.
There you go.
Oh wait, why did it not find it?
Does the file exist?
Yeah, hello JSON.
Is it looking in the files directory?
Yeah, files, hello. Oh wait, whoops. Of course it doesn't exist if I append it here. Let's rerun. Curl x delete, let's go. Huh. Hold on. Oh wait, .html. Ugh. Yeah, we don't need the .html. The file already has it. Curl x delete. Success. It is gone. Yeah. So if you want to extend this, right, just I don't know, make a PR or something. And just, you can implement put if you like. And this is just a simple HTTP server that just shows how HTTP works. It's not as complicated as you may think, but as you add more features, it could get a bit more complicated, right? If you want to add like routing, like proper routing instead of just doing HTML files, then there's probably more logic. If you want to handle more requests at the same time, HTTP server, no, TCP server. TCP server, then you may have to add threading. And yeah, I think this is all I have prepared. Any questions, or I will just end.
What's in your Docker file?
Oh, this is just in case I wanted people to do it themselves. But I figured it would be just wasting time too much, so I just didn't do it. If you want to run it yourselves, there is code on GitHub. Let me just commit all this. Just yeah.
Wait, pip file and PyProject?
PyProject has some like settings for MyPy and rough. No errors, all linted. No type errors, okay. What's it? Yep, added, delete. Yay. Okay, this is all I've prepared. Thanks for watching.
Questions?
I'm so tired. Yeah, questions.
So thank you, Jason.
Yay.
What questions do folks have for networking or Python?
What's the difference between the HTTP server and TCP server in a code, point of view?
So for benefit of online, what's the difference between TCP server and HTTP server in terms of the code? So the HTTP server uses the TCP server, right? So the OSI stuff, the 7 layers, right? It all builds on top of each other. So HTTP lives on top of TCP. So everything that TCP does, the HTTP server can do, right? But it's just doing other stuff on top of that. Or at least, I'm not sure about how his code specifically was implemented, but generally, there's a TCP server.
It is literally just,
Inheriting.
yeah, on top of.
Yeah.
Yeah.
Okay. So the TCP server just handles, you remember the handshake, right? The SYN, SYNAC, ACK, and the FIN, FINAC, ACK. Like it does all that stuff. It does all the keep alive stuff. It does all the, the packet handling and all the port stuff. The TCP server handles all that. And then the HTTP server does that and more. Because again, because the OSI layers, HTTP lives on top of TCP. HTTP adds the stuff of, remember when we looked at the image that had the HTTP request, where you had like post / whatever, the header is the body. The HTTP server adds the logic to parse and work with that. So for example, the logic that Jason added to handle the delete method of an HTTP request, that's specific to the HTTP server. Does that kind of answer your question, or were you wanting to see more of the code itself? Huh?
It's okay.
Okay. Other questions? Yeah.
So, the HTTP and HTTPS, how actually different, how they work inside the code when they just HTTP?
Right. So.
without S?
So. Which way should I frame explaining this? There's a couple different ways to think about it, which are right and wrong. But I'll just do what might be easiest to understand. So the S you can think of as kind of wrapping the HTTP request in encryption, right? So what happens is it also has a handshake similar to TCP, but it happens at the higher layers where oh God, it's been a while and I'm afraid to say wrong. But basically, the server has a whole bunch of kind of encryption keys and all this kind of stuff. Asymmetric keys, right? So there's like a public and a private key kind of thing. And when the client makes a request, right, the server has, actually no, I'm not going to go that deep unless you want me to. But basically, when the HTTP request is initiated, the TLS part, the secure part, comes first, right? And says, hey, let's agree on how to encrypt the data. So they do all that stuff, all the TLS stuff. And then once that kind of encryption tunnel is made, then the HTTP request goes through that tunnel, which basically means like the client says, I'm sending this request, then it encrypts it with TLS, sends it to the server. And then the server does the same thing on the way back. Now there's a whole bunch of stuff about how that encryption tunnel is made, and tunnel's not quite the right word. Basically the agreement of how they're going to encrypt the data, right? Because when you do encryption, you have to have a key to decrypt it, right? So how do these two sides do that? That's all TLS stuff that it's been a while. I'm not super confident I can explain it properly, but just know that it adds encryption to each transaction, each HTTP transaction. Does that kind of answer your question?
Yeah.
Okay, cool. Other question? Yeah.
You said about TLS. TLS and SSL is the same thing?
So TLS is the modern version.
Yes.
People will still call it SSL just because it was called SSL forever. There we go. It's short for Transport Layer Security, if I recall correctly, which implies it's layer 4, but it's kind of not. Or actually, I don't remember. I don't remember all the details. It's all theory shit. But yeah, when people say SSL in modern times, they generally mean TLS. SSL at this point should not be used. It is not considered secure anymore. Everything is TLS 2 point something or 3 point something. But TLS is just like the newer version of SSL. Cool. Other questions? Going once. Going twice. Sold.
Yay.
Thank you, Jason.
Yay, thank me.
And so we're gonna probably do some photo stuff, unless people did not want to be in the photos. And then after this, we're gonna go get food. There's a chicken place right nearby, because we always do chicken. If anyone has dietary restrictions, we can try to figure something out. But yeah, do be sure to check out our Discord, especially if you have further questions. And then we can also, Jason, are you okay sharing the presentation and the code?
Yeah. The code is already on CodeSoul GitHub. The presentation, I'll share it with you again or something. Yeah.
You could just share it in Discord.
Okay. Yeah.
So if you want to review that stuff later, go on ahead. And as always, if you have future questions, like maybe you're like, wait, how did layer 7 work again or whatever, you can always message on Discord. But thank you everyone for coming. Hope you had a good time. Let's go get food soon.